Here is another paper 2 questions for math study. This one is about statistics. Question 2. The following table shows the internal assessment marks and examination marks for 6 students. So for every of the 6 students, they have a grade for the internal assessment and another grade for the paper 1, paper 2. On graph paper, draw a scatter diagram of the above data. Use the scale 1 centimeter to represent 2 marks on the x-axis and 1 centimeter to represent 10 marks on the x-axis. So I need to make the difference between 1 centimeter is 2 marks in the x and the 1 centimeter is 10 marks on the y. I'm not going to draw the diagram, but you need to do a graph paper, a properly diagram with the x will be horizontally and the y will be vertically. And the important thing is the scale. So they say 1 centimeter, the box is 2. So I will have the 2, 4, 6, 8. And I think that my maximum was kind of at 20, so I don't need to do more. And in the y-axis, 1 centimeter, they tell me is 10 marks. So if this is a 0, this is 10, 20, 30, 40. And I think it's enough to stop at 70 because that's the maximum marks I have seen. If you want to get all your points, make sure that you use a ruler, your scale in X is Y, is correct. You have the label, internal assessment marks, or X, it could be also enough. You have the correct scale in the Y-axis with the label examination marks, or Y, that will be enough. And you have 6 points nicely drawn on it. For the moment, there is no line, there is no regression line, it's just the points. Question B, write down the person product moment correlation coefficient, R, for the above data. So for this I will need to go to my calculator, add in the list 1 all my X values, 6 of them, in my list 2 all the Y values, the 6 of them, and calculate the linear regression that goes with it. So I cannot show you this in the calculator, but as I repeat, with the button stat and edit, I will edit my list 1 with the X value. I will edit then my list 2 with all the values that are not this, by the way. Then I go back to stat but this time not edit, but calculate calculation, and I will go for the number for linear regression. Doing that in the calculator, I will get the linear function y is equal to ix plus b, give me a value for a, for b, and I have here the Pearson correlation coefficient. That is not that value, but I'm going to show you. So I repeat that in the proper data in my list 1, adding the proper data in my list 2. These are my X values, those are my Y values. Going to stat calculate linear regression. I get the value of R, Pearson correlation coefficient, is a number 0.981193 and so on. Remember that we want to have these to 3 significant figures. That's enough. So 0.181. That's my Pearson correlation coefficient. PII describe the correlation between the internal assessment mark and the examination marks. So for this I need to remember that if the R is bigger than 0, the correlation is positive, which is the case, it's a positive number. And then to see how strong it is, we divide this into 4 little pieces, the 0 to 0.25, 0.5, 75, and 1, being this region very weak. Here is a weak correlation, here is a medium correlation, and here is a strong correlation. So in our case, I can say that is a strong correlation, but don't forget to say it's a strong positive correlation. So that's the answer to the question, a strong positive correlation. Next question, C, find the mean internal assessment mark and the mean examination mark. So again, for these ones, we need to go to the calculator. How we calculate that? Well, we need to go to stats calculate, but we are going to use the one variable statistics. We're interested in only the x or only in the y. So if you remember, we have our x variables in the list 1 and our y variables in the list 2. So we will need to do this twice. For the x, we will put the list 1. We don't have any frequency. We calculate, we'll get the mean as a value. These are not the values. And we have to repeat that again for the y. In this case, we will choose the list 2. And again, no frequency list. And we'll have the y value with the value that corresponds. So with the proper values, list 1, the x mean is 13.33333. So that's correspond a mean of 3 significant figures, remember? 13.3. With the list 2, the x mean is what I'm going to call y, is for me the y mean. And again, 3 significant figures, 53.6 will make it 7. Okay, so that's the values I'm looking for. Next question, plot and label the point x and y mean in the scatter plot. That's easily done. And then write down the equation of the regression line for y on x. So that's the mean value, the 13.3, approximately 13.43, and the 53.6. We already did in stat calc linreg, linear regression, that other than the Pearson correlation coefficient, it gave us the regression line, and I have a value for the A and a value for the B. These are not the values, but show you what you see in your calculator. With the proper values, that's the equation, the regression line we have. The value of A with the x, the value of B without the x. With I need 3 significant figures, I go for 2.14 x, that's the A, plus 25, 3 significant figures, I need one more, I put at 2. That's the regression line. Use the equation from part E to estimate the examination mark of a student who scored 8 marks on their internal assessment. So 8 is the x, and we want to calculate the y. We're just going to plug this into the equation. So plug in 214 times 8, which is the x, plus 25.2. I put this in the calculator, and the result is 42.2615, and so on. Remember that I want just 3 significant figures, so 42.3. That's the result for the question. G, draw the regression line y on x on your scatter diagram for part A. To draw the regression line on top, please use a ruler. Make sure that you go through your x mean, y mean. Now what is also important is to have the perfect y-intercept. If I know the formula, what is my y-intercept? The 25.2. So make sure that you have a point in the 25.2 more or less. You are going through your mean and then use a ruler to draw the line. Last question. A new student scored 30 marks on her internal assessment, the X, and uses the above data to estimate that she will score 89 marks on the examination. Okay, she's using the formula with the X to have a value about the Y. State whether this estimate is reliable and give a reason for your answer. So we'll go back to the graph, and if we try to put her 30 marks, what do we see? It's out of range. It's out being my maximum 20. So even if I have the impression that here in this range I have a line and it's a strong positive correlation, if you remember, well, outside of the range I don't know what it is. It's an extrapolation I cannot say anything about. So I will explain that the X value, this 30, is out of the range where I was taking the data. So this is called an extrapolation. And the idea is that no, I cannot use my linear regression out of my range. So no is not reliable. Not reliable. And that's the end of the question 2.